Hi everybody, today we're talking about the floor and ceiling functions. In many math and computing problems, we perform calculations that result in decimal values, but the final answer needs to be a whole number. To handle this, we use two special functions called the floor function and the ceiling function. The floor function takes any real number and rounds it down to the greatest integer less than or equal to that number. In other words, it always goes to the lowest whole number. And what's important to remember here is that we're not doing regular rounding. We are always rounding down. The floor of 8.01 is 8. The floor of 4.25 is 4. The floor of 3.7 is 3. So even though it's over that 0.5, remember you're going down, which goes to 3. Negatives can sometimes be a problem because you aren't just throwing away the decimal place like you are in our other numbers. Here you really have to think about which integer is less than the one I've given you, which means the floor of negative 2.3 would be negative 3. The ceiling function does just the opposite. It rounds a number up to the smallest integer greater than or equal to the number, so you're always moving to the next highest whole number. And again, this is not just about rounding, so even something small like 8.01 is going to go up to the number 9. 4.25 will go up to 5, 3.7 goes up to 4, and negative 2.3 goes up to negative 2. Let's try a few examples. What do you think the floor and ceiling of 4.6 are? Well, we know the floor is going to be lower, which is 4, and we know the ceiling is higher, which would be 5. What about the floor and ceiling of negative 1.2? And remember to be careful with the negatives. Here the floor is negative 2 and the ceiling is negative 1. Let's talk about what happens if you get an integer. In that case, the floor and the ceiling will be the same. If I give you 7, the floor and the ceiling are also both 7. The floor and ceiling are very common functions, and you'll find them in programs like Excel. In Excel, notice it's floor.math and ceiling is ceiling.math. Here I have a very small list of numbers. I'm going to type equals and start typing floor. There are multiple floors, so we want to pick the one that says floor.math. And then I'll highlight the number, and then I can copy that down. Notice in each case we get the integer that is less than the given number. Let's do the same thing with the ceiling. Again, I type equals and I start typing ceiling, and I'm looking for ceiling.math. I'm going to click back on the number and then duplicate that function down. You can see there is a difference of 1 between the floor and the ceiling for each of our numbers. So let's talk about a couple of ways this might be used. We might use this for pagination and UI logic. When a website displays search results or items from a database, it often limits how many appear on each page. So let's say we had a total of 55 items in our search result. Each page is only going to show 10 items. To determine how many pages we need to divide and then use the ceiling function. So for our 55 results, when we divide by 10, we get 5.5. We're going to use the ceiling function to get 6, which says we have 6 pages are required to display all items. When searching a sorted list, like a binary search, we often need to find the middle index. So say we had an array of indices 0 to 9. The midpoint is 0 plus 9, which is 9, divided by 2 is 4.5. When we talk about arrays, we have to have integer indices. To give us an integer for our index, programming languages typically use the floor function and the integer division, which says we'll take the floor of 4.5 to get 4. So I want you to remember that floor and ceiling functions are useful when a calculation produces a decimal, but the result must be a whole number. The floor function rounds down to stay within limits, while the ceiling function rounds up to ensure nothing is left out. Together they help turn calculated values into usable whole numbers in specific context.